Okay, let's try this video again. Maybe I can be a little clearer on what's happening because I think a lot of people are struggling with this. So what you're doing is you're finding the area of the shaded region, right? And so we have no formula that will allow me, what I could do here is I could, make all these little shapes inside here. And the problem is I might not be able to find these little measurements on the sides. So rather than do all of that, what I can do is I can take and find the area of this whole triangle, right? This whole triangle, pretending like the white part's not even there, and then find the area of the white part, and then just remove that with subtraction. And so that's what you're doing in this case. And so in a triangle problem, you're using the area formula that is 1/2 base times height, or base times height divided by 2. I usually, for whatever reason, do base times height divided by 2, but you can do 1/2 base times height. That's the exact same thing. So the first thing you're going to do is you're going to determine what are the measurements of the big triangle. The base is 32, and the height is 28. And so when I determine the area of this, I'm just going to do base times height divided by 2. And the area is going to be, hold on, I'm pulling my calculator really quick. Looks like 448 for the area of this big triangle. So that includes, this area includes the white part, okay? This area of this big triangle includes this white triangle in the middle here. So then I'm going to find the area of the smaller triangle, the white triangle. And the base is 21. And the height is 20. Oh, I'm sorry, it is not. The height is 18. Being careful here with my measurements. Here's the 18. Here's the 18. And so my area is going to be base times height divided by 2. And so, and I've got two problems here. I should have changed colors, but you get the idea. And so the area of the little triangle inside, or that white triangle inside, will be 21 times 18 divided by 2, which is 189. And remember what I said, double check your multiplication and all that, just to make sure that you don't have a careless mistake, because it's so easy in these problems to type something wrong in the calculator, and I would hate for you to miss it for that reason. Okay, once you have the area of the outside figure and the area of the inside figure, then you can just subtract them. So here is the first step, find the area of the big triangle. Here is the second step, find the area of the inside triangle, so outside, inside. And then your third step is going to be to subtract the area of the big triangle minus the area of the little triangle. And that's going to give you your solution to this problem. So we're going to do 448 minus 189, and that's going to give us 259. And that will be our final answer for this problem, 259. Okay. These are the easy ones. The rectangular ones are the easier ones. Just be careful of when you're writing to a decimal, making sure that you correctly round to the nearest hundredth. Okay, so we want shaded region again. And the only way we're going to do that is to get the whole rectangle and then just remove the white part, okay? So looking at our outside figure, and we're going to start the same 3 steps, we want to find the area of this outside figure. Okay, so let's look at the measurements of this outside figure. It is 29.1 by 29.1, so it is a square. And don't forget that we can find the area of all rectangles and squares by just multiplying length times width. So if I want to find the area of this square, I can just multiply 29.1 times 29.1. And that gives me an area of sorry, just typing it into my calculator here. So 846, and this is where you have to really start being careful with making sure that you're writing these numbers down and you're making sure you're writing them down correctly, because so many decimals, so hard to make careless mistakes. 84681. Okay, so there's my outside figure. Then I'm going to find this white piece so I can remove this white piece from the picture. Okay, so the second thing I'm going to do is find the area of this small inner square, which is 9 by 1, and that does not look like 9 by 1, and 9 by 1. Okay, and I can find the area of that the same way as the square above, just multiply the 2 sides together. So 9.1 times 9.1. And that's going to give me, let's see here, 9.1 times 9.1 is 82.81. And again, this takes me a little bit longer just because I'm typing everything in twice and making sure that I have written the right thing down. Okay, so then my last step here is going to be to find the area of the shaded region, which means I'm just going to take the big area, or the area of the entire figure, which is 846.81, and I'm going to subtract the inside figure, the white figure, which is 82.81. So let's see, that is 6.81. And I get 764. So just a recap, first I found the area of the outside figure, this whole thing. Then I found the area of this white square on the inside. And then I just took the entire area, subtracted away the white part, and that left me with the pink part. So my answer is 764. Okay, so now we're looking at what is probably the hardest type of problem in this section. It's the same exact thing. We're going to find the area of the entire big circle and subtract away the area of the entire small circle. And so we want to think about this sort of the same way. So I'm going to start with just drawing a picture so I can get some idea of what I need here. So I have a big circle. I'm going to find the area of that. And then I have a littler circle, and I'm going to find the area of that. And remember that the area of a circle is pi times radius squared, right? So the measurement that I need when I want to find the area of a circle is the radius, which is the distance from the center of the circle to the edge of the circle. The distance from the center of the circle to the edge of the circle. Well, we have two measurements, but neither of them are a radius. One of the measurements is this little part, the distance from circle to circle, or circle edge to circle edge. And then the other measurement is the circumference of the inner circle. But the nice thing about having the circumference of the inner circle, which is that distance around, is that length will help me solve for the radius of the inner circle. So in a problem like this, where I'm given circumference, the very first thing I have to do is find the radius using that circumference. So I need to find that little r of the inside circle. Okay, and I'm going to do that using circumference formula, which is 2 times pi times radius. Okay, and so they give me c equals 163.28, and so I'm literally just going to replace c with 163.28. And at the same time I do that, I'm going to replace pi with 3.14 because they tell me to in the prompt. So that's going to be 3.14 times the radius, okay? And the fact that I have a r right here is actually really beneficial for me because I'm about to solve for this r because I need this little r right here in order to find the area of that inner circle. So now I'm just going to multiply 2 times pi. And 2 times pi, or 2 times 3.14, is just 6.28. So now I have an equation that says 163.28 is equal to 6.28 times r. And I can solve for r by just undoing this multiplication here using division. So I'm dividing both sides of my equation by 6.28. And so I'm just going to grab a calculator. So that's going to be 163.28 divided by 6.28, and that's going to give me 26 even. And so what I have just found, this r right here, this is of this small circle that they gave me the circumference of. This 26 is the distance from the edge of the circle to the center of the circle. This is my little r. So right here, this value is 26. So I now have enough information actually to find the area of the inner circle, right? Because I can now just plug my little r in, and pi is going to be, area is going to be pi times 26 squared. And we'll come back to calculating this in just a moment. Okay, so now we need the area of the bigger circle. So the second thing you have to do is find the radius for the big circle, which is the distance from the center of the circles all the way out to the edge of the bigger circle. And I actually know enough to be able to find this now, because I know the distance from the center to the edge of the little circle is 26. And I know that the distance from the edge of the circle to the edge of the circle is 9, right? The edge of the little circle to the edge of the big circle is 9. So I can actually just add together the little radius plus the given. So I can just say 26 plus 9 and get that the radius of my bigger circle is 35. So this radius is going to be 35. And now I have enough to find the area of the bigger circle. It's going to be pi times 35 squared. Now I'm just going to use my calculator to find the values for these. And notice that it tells me to use 3.14 for pi. So I'm going to go back in here and I'm going to find, excuse me, I'm going to find these areas using my calculator. So when I do that, that's going to be 3.14 times 35 times 35. That's what to square something means, to multiply it by itself. So 3.14 times 35 times 35. And my area that I'm getting for the bigger circle is 329.7. And then I want to find the area of my little circle. So I'm going to do 3.14 times 26 times 26. So I'm just calculating the area now using my calculator. Wow, I think I might have calculated that first one wrong. Remember I said to type twice. I didn't type twice. I'm actually going to erase this, and we're going to go back in here and we're going to retype in this top one. All right, try again. 3.14 times 35 times 35 is 3,846.5. The reason I suspected that I got this this top one wrong is because when I typed in this bottom one, which should be the smaller circle, I got a bigger area, which is definitely not what was supposed to happen. So I'm getting 2,122.64 for this bottom one. And I'm going to type that in one more time because mistakes. 26 times 26 to be, okay. All right, so, and I hadn't labeled these, but that step 1 was finding little r using circumference formula. Step 2, add the little r and the given. Step 3, find the area of the big circle. Step 4, find the area of the little circle. 5th step, just subtract the white area from the big circle, and that will give you the pink. So we're going to take 3, 8, 4, 6.5, and we're going to subtract 2, 1, 2, 2.64. So 3, 8, can't type, 3, 8, 4, 6.5 minus 2122.64. And I'm getting 1723.86, and it so very politely is already in the hundredths place, 2 places after the decimal, so I don't have to worry about any rounding. Okay, so these are the 5 steps to solving for the pink area given a circumference, okay? Okay, I'm going to do a second example of subtracting 2 circles when you're given the circumference, because this is definitely the hardest one. So, again, I know I need to do circle minus circle, right? Big circle minus little circle. And I know to find the area of a circle, I am looking for pi times radius squared. And so my radius, my distance from the center to the edge of the circle in this problem is unknown, okay? Like I don't know this. What I do know is that the distance all the way around, or the circumference of that circle, is 59.66. And I can use circumference to find that length of radius because I know the circumference is 2 times pi times the radius, okay? This is a pi symbol. So my circumference, I'm just going to plug that in. It is 59.66, and that's going to be equal to 2 times pi times the radius. And remember, with IXL, you always use 3.14 in place of pi. And so 2 times pi is always going to be 6.28. So really, it turns out that if you're given the circumference of a circle, every single time you can find the radius of that circle by by dividing by that 6.28 value, that 2 pi value. So if you wanted a shortcut, given circumference, you can find the radius, right? So the radius is always going to be circumference divided by 2 pi, which is 6.28. And that will make your life a little easier, okay? So 59.66 divided by 6.28 is 9.5. Okay, so what that value just told me is in the little circle, which is maybe so small I can't write 9.5, that little radius is 9.5. In this little inner circle, my radius is 9.5. That's what that just told me, okay? So I can begin to find the area now of this little circle because I have the radius. All I need is the radius in order to find the area of the inner circle. So pi times 9.5 squared will give me that. Okay, the next thing I need to do is find the area of the big circle. Big circle radius goes from the middle all the way to the edge of that outer circle. So we know this piece from edge to edge of the two circles is 20.8. And we know this piece because this piece is just the inner circle, so that's 9.5. So we can actually just add these together to find the radius of the big circle. So that's going to be 20.8, that given value, plus the inner radius, which is 9.5. So 9.5 plus 20.8 is 30.3. So what this tells me, this 30.3, this tells me this radius of the big circle, this one right here. So that is 30.3. Okay, so I can now find the area of the bigger circle by doing pi times 30.3 squared. And so now I'm just going to prep this to type it in my calculator. I'll be typing it in as 3.14 times 30.3 times 30.3. Just expanding it out. 30.3. Okay. 3.14 times 30.3 times 30.3. And I'm getting a big number, 2, 8, 8, 2.8, 0, 2, 6. And I'm going to go ahead and, because I messed up on the last one a little bit and I had to go back, I'm just going to double check that. So 3.14 times 30.3 times 30.3, 2882.0. Okay, I get it. So now we're going to do this one, and I can expand it. I'm going to multiply 3.14, which is that pi symbol, times 9.5 times 9.5. So 3.14 times 9.5 times 3.14 times 9.5 times 9.5. I'm getting 283.385. Okay, so where am I at? Step 1, use the circumference to find the radius by doing circumference divided by 6.28. Step 2, add the small radius to the given value from edge to edge to get the big radius. Step 3, use the big radius to find the area of the big outside circle. Step 4, use the small radius to find the area of the small inside circle. Step 5, take the big area, subtract away the white small area, and that leaves you with the green stuff. So we're going to take 2, 8, 8, 2.8026, and we're going to subtract 283.385, and we're going to get some number. Let's see what it is. I'm getting 2599.4176, and I'm glad we got this problem because we can now talk about the rounding piece just in case you're still struggling with that. What I'm doing right now is I'm actually just typing it in again because mistakes. 283.385. 25994176. Okay, so remember that we want to be rounded to the nearest hundredth, and so I need to be at the second or 2 numbers after the decimal place. So the question is will the 7 round the 41 up? And the answer is yes. So 7 rounds 1 to 2, or 41 to 42. And so when we type this in, we'll type 2599.4176. Okay. Oh, I'm just lying to you. See? I'm telling you, it's easy to make little mistakes in this kind of problem. Okay, so here it is. Another example of how to find the area of the shaded region when all you get is the circumference of that inner circle. Okay? All right, so this circle question is given the radius and from edge to edge, okay? So this one's actually easier than the last 2 circle questions. Let's see, let's get it started. We know that we're gonna need the big circle, and we know we're gonna need a little circle. And we know to find the area of a circle, it is pi times the radius squared. I don't know what happened here. This does not look like a pi though. Okay, so I need this distance in the big circle, and this distance in the small circle. And I see small circle, when I say that, I mean this inner white circle, right? I'm using the same color, that's crazy. And so I actually know that this one is 10.9. I already know this one. Isn't that nice? I don't have to use any formulas to solve for it. It is given. So I can actually already find the area of this inside circle by just doing pi times 10.9 squared. Whoa. And I'll do that in just a moment. So now I need to find the area of this big circle. In order to do that, I need the radius of this big circle, which would be the distance from the center of the two circles all the way to the edge, right? And I know edge of the circle to edge of the circle is 10.4. And I know that from the edge of the circle to the center is just the radius of the small circle. It's 10.9. And the 10.4 came from this given value down here, in case you missed it when you glanced. So I can actually find the little radius of the big circle, excuse me, big radius of the big circle, by just adding that given 10.4 to the small radius. So in the previous two examples, this would be your step 2, right? Adding the given to the small radius. And so 10 point, clear my calculator, 10.4 plus 10.9 is 21.3. So the small radius here is, well, actually, let me put it here so I have room, 21.3. And so now I know this length right here, it's 21.3, and I can actually go straight into working the area of this bigger circle. So it's going to be pi times 21.3 squared, pi times radius squared. And I'm just going to give us a little pause here to save time in this video because I've shown you how to do this part a couple of times and get some numbers. Okay, so now I've got some numbers here. 3.14 times 21.3 times 21.3 is this 1400-ish number. And then 3.14 times 10.9 times 10.9 is this 373-ish number. And so now I have enough information to find the blue shaded region simply by subtracting the big area minus this smaller area of the white circle. So final step here is just going to be to subtract. And I'm going to pause again for the writing of this. All right, so big area 1424 minus small area 373 looks like this. And when I subtract, I get 1051.5232. Rounding to the nearest hundredth again, because, you know, that's a thing that has to happen correctly. Here's my hundredths place, this 52, 2 places after the decimal. And the question is is the 3 enough to round the 2 to a 52 to a 53? And the answer is no, it is not. And so my answer is just going to be 1051.52. 1051.5. And I did 3. See, I'm telling you, so easy. That twice now that I've typed it in wrong the first time. So, given the radius, go straight into your work. Just find the big radius by adding the given to the small radius, and then just subtract. That's it.